What is sigma AB?
219, sir.
219. What is the unit? What is the unit?
Newton per mm square.
Okay, 219 and 048 MPa. Sigma BC minus 85.7
Minus 85.7.
MPa. That's it. This is how it has to be done. At least one reaction force we should consider. I cannot just blindly. I can give the justification why it cannot be done in the way which we have done. Okay, give me some time. I'll think out and tell you. The method is okay, but I don't know why exactly I didn't get the answer. I'll tell you. There's some tricky thing. I will tell you. Okay. Next. I'll ask you a question. This you should answer. Okay. Now, if we ask to find the deformation of this bar, how do you go? Deformation for yes. If you ask to find the deformation of this bar, how do you go ahead and solve? How do you go ahead and solve? Will you find the take the section on each section? Will you take like this? Will you take a section like this? Tell me.
No, sir.
No, it is not required. You should always assume like this. Assume that this is one rod. This is some material. Below that, there is one more rod. One more rod. Below that, there is one more rod. One more rod like this. Assume that I have this. Okay. Assume it is 3D. I have written like this. Okay. Now this is copper. This is steel. This is cast iron. So if I place a block like this, the entire weight, for example, this is assume 100 kg, 100 kg. Whatever 100 kg is transmitted to copper, then steel same 100 kg, then cast iron, it's same 100 kg, isn't it? Similarly, on the same lines, if I apply 20 kilonewton throughout, there is a section this 13 diameter and 20 taper section also 20 kilonewton, and also in that 20 this part 2 section 2 also 20 kilonewton, and also in section 1 this 20 kilonewton only. Okay, you should not forget this is called a series arrangement. But the deformation total will be equal to sum of all the deformation of each and every section, each and every part, but the load remains the same. Load carrying by each section, each part is the same. Whereas if you take the parallel arrangement like this, let us consider 4 this is some table. Okay, you will place some weight like this. You place some 100 kg weight and some block you will place. It is on the table. Assume that is on the table. This table is constrained like this. This table is constrained. It is fixed. It is fixed to the. If this is 100 kg, we'll assume that 25 kg here, 25 kg here, 25 kg, 25 kg here. This can be copper, this can be mild steel, this can be cast iron, this can be brass. This arrangement, in this arrangement, the load, total load, I can write, total load is equal to load on each section, copper, cast iron, mild steel, okay, plus your brass, plus your aluminum. So total load is equal to sum of all this load, but the deformation remains the same. Deformation is copper is same, deformation steel is same, deformation deformation in your brass is same. All the members, all the four members deformation is same, but the load is equally shared. Whereas in this case, load remains the same. Load in aluminum is equal to load in copper and load in mild steel, but the deformation is equal to sum of deformation of each section. Okay, this you should understand. This is known as series arrangement. Series arrangement. This is called as parallel arrangement. In parallel arrangement, load is shared. Equal load is shared. Whatever ratio load is shared, but deformation remains the same. Then we should assume whatever this table is there, this supporting structure is rigid. It will not undergo any deformation. Okay, and then here the loads are equal, load remains the same, deformation is shared. So in context of this problem, this holds good. This holds good. Our load remains the same. Therefore, each and every section load remains the same. Therefore, P of AB load is equal to 20 into 10 power 3 into length 500 by area 50 pi d square by 4 into Young's modulus. Similarly here, similarly section 2, section 3 you should do it. Okay, and go ahead. Let's go to the next concept that you should do in the examination. If you ask only directly some load to 20 kilometer, 100 kilometer, you should not take sections, and each section you should not take the section. The load remains the same. It is series arrangement. The problem is like this. See, in this problem, the problem is like this. The allowable stress AB, C, the allowable stress of this is sigma AB is equal to sigma BC. In both the section, the allowable stress is 100 MPa. The maximum stress this structure can withstand, the part AB or part BC, is 100 MPa only, and it is subjected to a load of P2, which is equal to 200 kilonewton, and then this is P1. P1. We should find P1. He has asked to find P1 in such a way that the load in either of the part should not exceed 100 MPa. The load in either of the section, either of the part should not exceed 100 MPa. We'll go as usual. First, I will take the part 1, P1. Okay, this will be P of AB summation of forces in y direction is equal to 0. Summation of forces in y direction is equal to 0. I can write minus P1 minus P of AB is equal to 0, or P of AB is equal to minus P1. P of AB is equal to minus P1. Next, second section I will take. P1, P2 is equal to 200 kilonewton. This is PBC. Minus P1 summation of forces in y direction equal to 0, minus P1 minus 200 minus PBC is equal to 0, or PBC is equal to minus of P1 plus 200. Okay. Now, yes, given the allowable stress, is 100 MPa. Let us find sigma AB. It is equal to P of AB by area of AB. Area of AB, its length is, this length is 80 mm. This length is 120 mm. This area of cross section A1 1500 mm square, A2 2600 mm square. P of AB sigma maximum allowable stress is 100 MPa. 100, okay, 100, which is equal to P of AB, okay. Forget about it, minus P1 or whatever. P of AB, if you want to write minus P1 also, you can write. If you want P of AB minus P1 divided by area of AB 1500. Okay, therefore P1 is equal to, minus P1 is equal to 1500 into 100, which is equal to P1 is equal to minus 150 kilonewton. P1, which is equal to minus 150. Forget about this, it will not matter. P1 is equal to 150 kilonewton. Next, if I take sigma BC, which is equal to PBC by ABC, which is also maximum stress on this should not exceed 100 MPa. 100 PBC, which is equal to minus, if you want to write minus 150 kilonewtons, good, 150 minus of minus 150, okay. PBC minus 150 plus 200 by area BC, PBC minus P1 plus 200, okay, plus by 2000, okay. What we'll do, we have find that P1 is equal to minus 150 kilonewton, right? We'll substitute P1 is equal to minus 150 kilonewton and find sigma BC. Okay, you'll come to know what we are doing by 2600. Tell me what is sigma BC. And then what later we will do, we'll find some sigma BC, will find P1 and substitute in sigma AB and find what is sigma AB. When we do it, we'll come to know. Tell me what is this sigma BC, minus 150 plus 200 by 2600.
Zero point 0192.
0.0192. Give a moment. If the allowable stress in compression, the problem is if the allowable stress in compression, you can take minus 100 if you want. allowable stress in compression minus of minus 100, you can take minus of minus 100, which will be equal to 150. I have missed that term. Allowable stress in compression. That is sigma AB is equal to sigma BC, which is equal to minus 100 MPa, which will come to plus 150 kilonewton, which is plus 150 kilonewton. How much you're getting? Minus. Did you understand that statement? Is I missed that. If the allowable stress in compression is 100 MPa, okay. What is sigma BC?
minus 0.01923.
No. It's 150 plus 200 by 2600. How much are you getting? Into 10 power 3. You have to do into 10 power 3. How much are you getting? Into 10 power 3. 150 kilonewton, right? 150 plus 200 into 10 power 3. How much? What is sigma BC? 150 plus 200 into 10 power 3 by 2600.
134.61.
134.61. Minus 134.61 MPa. You should note that by taking load is equal to 150 kilonewton, my sigma BC, the stress in section 2 exceeded sigma BC is greater than 100 MPa, which is minus 100 MPa. Therefore, this load is not feasible. I cannot take this load into consideration for calculating. I have to find the other way around. What I will do, I will take this now. I will take second part. Shall I take sigma BC, which is equal to PBC by ABC. Sigma BC is minus 100, which is equal to PBC is minus P1 plus 200 by area of BC, it's 2600. Can you tell me what is P1 from this? Sorry, that's P1. Minus, cancel it out. Is it 60 kilonewton? 60 kilonewton. Multiply 100 into 2600 by 10 power 3 minus 200. Don't always take alpha is equal to that thing. Only when you have two equations, then you can take the two terms. How much? Hello? Are you there? ಮಾತಾಡ್ರಪ್ಪ ಯಾಕೆ? How much are you getting? $100 to 2600 by 10 power 3, which is equal to 100 into like this. 100 into 26 by 10, which is equal to 200 plus P1, 200 plus P1, which is equal to 10 times 100, 260, P1 is equal to 60 kilonewton. Are you getting this? Are you getting this?
Yes, sir.
ಯಾಕೆ ಯಾಕೆ ಹೇಳಲ್ಲ ನೀವು? ಯಾಕಮ್ಮ ಹೇಳಲ್ಲ? ಯಾಕೆ? P1 is equal to 60 kilonewton. Next, we have got obtained P1. Let us substitute the sigma AB, which is equal to P of AB by A of AB. P of AB is in turn equal to P of AB is in turn equal to P1. That is P1. I can write minus 100, which is equal to minus P1 by area of AB. Sorry, I can't write this. Sigma AB, which is equal to minus P1 by area AB, which is equal to minus P1 is minus 60 into 10 power 3 by 1500. Can you tell me the permissible sigma AB now? Sigma AB 60 into 10 power 3 by 1500. Can I write 6 into 10 power 4 by 15 into 10 power 2, or 600 by 15, 15 for the 60, 40 MPa. Therefore, by taking P is equal to 16 kilonewton, the stresses in sigma AB is equal to 40 MPa and sigma BC, which are taken 100, is equal to 100 MPa, are within permissible limits, allowable limits. Okay. Okay, this is how you have to calculate, not just by calculating sigma AB and obtaining the value 150 kilonewton itself. This will not suffice. This is coming above 100 MPa. Okay, minus 134.61 MPa. But my structure is not designed to withstand that much load. It should be well within 100 MPa. So I have done like this. So this is the way. Have you understood? Have you understood?
Yes, sir.
Okay. Next problem, we'll go ahead. All types of problems are covered. Next, we are left with that Young's model finance ratio, that those types of problems, which I will do 1 or 2 classes next week. I will take if possible. Okay. Problem is like this. A steel circular bar, I'll write AB, CD is as shown in the figure. Bar is subjected to axial load 60 kilonewton on 120 kilonewton at B and C. Find the loads shared by each part. You can take RA like this, RB like this. If you want, however you want to take RA and RB. What are the loads in each part he has asked to find? There is AB, BC, and CD. And the displacement of point B. What is the displacement of point B? This is the displacement of section AB. displacement of section BC individually. It has asked what is the displacement of section, what is the displacement of point P in the sense, what is the displacement of section AB, displacement of section BC in the sense, displacement of point C. This is how you have to understand. Take E for steel is equal to 207 GPa. Okay, as usual, same. This is last problem I'm doing on this type. As usual, go ahead. RA like this. P of AB. P of AB is equal to summation of force and acceleration equal to 0. P of AB is equal to RA. Next, I'll take the second section. RA like this. 60 kilonewton. PBC. PBC plus 60 minus RA. PBC is equal to RA minus 60 kilonewton. PB is equal to RA minus 60 kilonewton. Last section. Are reacting like this. One reaction force has to come to picture. 60, 120, PCD, PCD plus 120 plus 120, PCD plus 120 plus 60 minus RA is equal to 0. PCD which is equal to RA minus 180 kilonewton. Kilonewton. Next, the total deformation of this entire structure is equal to 0. One section can be in tension, other section can be in compression. Whereas when you consider total deformation, the entire structure is entire structure deformation is 0. Let me write directly. P of AB, P of AB is RA. RA, if you want 10 power 3, you can include 10 power 3. RA, if you want, let us include RA, 10 PA, LA. LA, it has given the length as 320 mm. And this length as 400 mm. This length as 480 mm. Or you should write the units also. Due to the constraint of time, I am writing. You should include all the units, or if else you will not, you will lose the marks then. PL 320 PL area of cross section pi into d square by 4 PL by A into E 207 into 10 power 3 plus RA minus 180 into 10 power 3 into 400 by pi d square by 4 into 207 into 10 power 3 plus RA minus 60 into 10 power 3 into 480 by pi d square by 4 into Young's modulus 207 into 10 power 3. Tell me what is RA. You tell me what is RA. You are in the calculator, 0 is equal to alpha, and then RA instead of RA, type X, and obtain the value of RA. The 10 minutes only remaining. Calculate soon. All of you switch on your videos. Let us see your what are you doing. Switch on your videos. Shashi, Abdul Razak, Chetan, Dhruti, Mekala, Raghavendra, Rakesh, Sanjay, Sudan. Switch on your videos. Switch on your videos. Yes, whether you're writing or not, switch on your videos. Shashi, Abdul Razak, switch on your videos. Dhruti, Mekala, Raghavendra, switch on your videos. Switch on Madri, Chetan, I'm seeing.
1 minute, sir. 1 minute, sir. We have to give permission to it.
I have to give permission. Okay. What permission I should give? What permission I should give?
No, sir. No, sir. We should give an Android. We have to give that permission to access camera.
Okay. Mekala, Elama Bukku, very good. Rakesh, ಬರ್ಕೋತಾ ಇದ್ದೀರೇನ್ರಿ? ಸುಗನ್, ಆರ್ ಯು ರೈಟಿಂಗ್ ಎಲ್ರಿ ಬುಕ್? ಬರ್ಕೋತಾ ಇದ್ದೀರಾ? ಹಾ. ರಾಘವೇಂದ್ರ is calculating. Sanjay, show me the previous problem, Sanjay. Okay. Others? Others? What are you doing, others? It is not a movie. Abdul Razak, Shashi, ಎಲ್ರಿ video? Abdul Razak, show me.
Yes, sir.
Yes. Where are you? Is Abdul Razak? Sugun. Dhruti, you are calculating Dhruti. Okay.
So just now I showed, sir.
Okay, okay. Abdul Razak, where is your book?
Yes, sir. I showed.
You are sure? Show me.
Yeah, I
your book.
showed just now, sir. My video is not working. Okay.
Okay, let's see. Okay. Tell me the value. What is the value of RA? You can cancel this. 10 per 3 through. Sorry, I made a mistake here. Okay, that's fine. RA into PBC is how much? RA. Sorry, PBC is. Sorry, give me a moment. PBC. PBC is RA into 60, right? RA minus 60. RA. PBC, RA minus 60. PCD, RA minus 180. Minus 180, small correction. You can take pi throughout common, it is completely 0. Pi d square by 4 also 0. 207 is also 0. 207 to the power 3. Should have been done like that only. Tell me what is RA? ಇನ್ನು ಬರ್ಲಿಲ್ವಾ ಎಷ್ಟು ಬಂತು ರಾಘವೇಂದ್ರ ಶಶಿ ಅಬ್ದುಲ್ ರಜಾ
Sir, I'm doing in Calci, sir. 2 minutes.
Okay, it's taking time. Okay.
Sir, in Calci, we cannot do such lengthy ones, sir. The last part, it's not
No.
taking full.
Okay, what you can do, you take 207 into 10 power 3 throughout is 0. If you take 207 into 10 power 3, 207 if you take, it is through completely 0. Okay, let me simplify here.
We can take one pi, sir. 207 and pi.
Pi 4 also. Pi d square by all this on pi by 4 into 207 into 10 power 3. But this 10 power 3 will not cancel then. Okay?
Okay, sir.
What you can do, 0, which is equal to 1 by pi by 4 into 207 into 10 power 3 into RA into 10 power 3 into 320 plus RA minus 60 into 400, RA minus 60 into 400 into 10 power 3 plus RA minus 180 into 10 power 3 into 480. Can you solve this? By also denominator by 30 square by 60 square by 80 square. This will be 0. This will be 0. RA into 10 power 3 into 320 divided by 30 square plus RA minus 60 into 400 into 10 power 3 by 60 square. RA minus 180 into 10 power 3 into 480 by 80 square. Okay, there is less than 1 minute time remaining. I will give the answer. RA, verify yourself, RA comes around 37.23 kilonewton. When RA is equal to 37.23 kilonewton, what you have assumed RA 37.2 kilonewton. Let us take, it is acting in the other sense. Summation of forces in the x direction is equal to 0. It is acting in the negative x direction minus, right here, minus 37.23 plus 60 plus 120 plus